All right, hello, this is Mr. Wallace. We are in Unit 7, the linear versus exponential modeling. This is going to be the Lesson 2 practice on page 6. We're going to be doing numbers 1, 2, and 3. All right, so the previous units we've been working on is really dove between the linear models, and then our Unit 6 was the exponential models. Now we're putting them together. So it's really important to tell the difference, okay? So here we go. Number 1, multiple choice. The data shown in the table below represents either a linear or exponential function. Which of the equations below best models this data set? Okay, so we're going to circle our answer. So remember, a linear model is a straight line. If we graph it, the slope is constant. So, for example, up 2 over 3, up 2 over 3, or plus 3 over 1, plus 3 over 1, right? The graph of an exponential all deals with multiplication, right? Times 2, times 2, times 2, or times 3, times 3, times 3, where the slope is constant, like plus 3, plus 3, plus 3, okay? And there is sun right there, so let me put down my blinds real quick, see if that helps. There we go. Okay, so we need to look at our table. First of all, wherever my x value is 0, my y-intercept is that number. So I know my y-intercept is 6. Let's see if I can eliminate any of these automatically, since my y-intercept is 6. Well, b, that has a y-intercept of 6 in slope-intercept form, right? So y equals mx plus b is my line, and y equals abx is my exponential. So it could be b. Let's see. Well, it can't be d, because that says -2 as my y-intercept. And then let's see, nope, it can't be a, because that first number in an exponential equation is always my starting point, always my y-intercept. So I eliminate a and d. Now, how we figure out which one is which, we have to look at our y values. What's the pattern going from left to right? Well, I see 24 and 12, I see there's a divided by 2, divided by 2, divided by 2, divided by 2. I know I was saying earlier that's all about multiplication. Well, if we divide by 2, it's the same thing as multiplying by 0.5. Dividing by 2 and multiplying by 0.5 are the same thing. So if we do 24 times 0.5 times 0.5 times 0.5, well, we see we have an exponential model, because everything from left to right is being cut in half, right? The y values are not constant. There's not a constant y value difference that's happening in between. So it's not letter B either. So it's letter C. All right, number 2, which of the equations below represents an increasing linear function? Okay, increasing means positive slope. Linear function means slope-intercept form, so y equals mx plus b. Circle our answer. Well, let's see. I can automatically eliminate letter A. I can eliminate letter C, because those are exponential. All right, so let's look at our two different y equals mx plus b equations. It doesn't really matter what the y-intercept is, because I just want it to be increasing. I know both of these are linear functions. Well, look at the slope. Which one is the only one with a positive slope? Letter D has a negative slope, -1, so it has to be letter B. Doesn't matter what my y-intercept is. It is a linear function, and it's increasing because it's up 4 over 3, up 4 over 3. And then finally for this one, number 3, which of the equations below represents a decreasing exponential function? Circle your answer. Exponential, so letter D is out. And, letter B is out. That is in slope-intercept form, just the y-intercept of 0. So let's see. Decreasing means that my growth rate, or my value that's in my parenthesis, decreasing means it has to be less than 1. That was a big deal with our last unit, right? So if we look at letter A, my growth rate, my number in the parenthesis, well, that's being doubled. That's more than 1, so that's increasing. Nope, so the only one that we have left is letter C, and that makes sense because my growth rate right here is less than 1. 0.98 is less than 1. So, okay, thank you so much.